welcome to the last and final example class, and also the last and final lecture, you could say, under nonverbal intelligence. So we had done questions, we had done about 11 questions in the last two example questions, in the last two example sessions. Now we'll be covering some more questions, just sort of like to ensure that we have covered every topic, right? So let's just begin. From the answer figures, select the cut pieces from which the problem figure is formed. Basically, you have an answer figure, you have many answer figures, and you have a problem figure. And you have four options here, A, B, C, and D. You need to see out of these four options, which is the piece from which the problem figure is formed, right? So I have four pieces here. I want to see of all of these four pieces, with which piece can I form the problem figure. I'll give you some time to sort of try to figure it out on your own, and then I'll discuss it, okay? Right. So, I mean, this time might not be a lot of time. I know that, like I always say, feel free to just pause the video if you feel like you need more time. Right. So anyway, here, okay, let's look at option A. You see four long lines. Here you have four long lines, okay? Then you see four short lines. Here you have four short lines. Then there is a, what is this? A black circle, which you have here, and a bigger, circle, white circle, which you have here. So the figure is up. So the only thing left is this. So you need to understand, in most of the figures, this outer box is not part of the figure. They will give an outer box. That is just to show that, the figure is contained in this box. The outer box in itself is not part of the figure. For example, even in the next question, you have an outer box and you have a Y-like structure inside it. So what we are asking about is just this Y-like structure, not the outer box. So in most of the questions, the outer box in itself is not included. So even if you're not able to get the outer box, it's fine because it's not mostly included in the figure, right? So A seems like a potential option. We can give a half tick. This is what I call a half tick, right? And this is a full tick. Yeah, moving on to B. In B, the problem is that you have two black circles, right? Here you only need one black circle. So not B. In C, what is the problem in C? You do not have a black circle. You need a black circle here, right? You don't have that in C, so it's not C. And then in D, you do not have a white circle. So you need a circle like this one, which you do not have, so not D either. So now this half tick, can be a full tick. You're sure that it is definitely A. So we have gotten the answer. We know that for the 12th one, the answer is A. Okay, we've gotten that. We're done with that. Now, moving on to the next question. From the answer figures, select the cut pieces from which the problem figure is formed. Basically, I need to see out of these A, B, C, and D, out of all of these figures, which is the cut piece from which I can form a Y. Okay, is there any figure wherein I have something like a Y is what I need to be looking at. Again, I'll give you some time. It's a fairly easy question. Just see if you can sort of figure it out. The time starts now. Right. So it's definitely not this Y, because here you need a straight line, right? You don't have a straight line. I mean, see, you have some straight lines here. If you take it and change it, maybe. But then if you look at B, you find that you have this figure in and of itself, right? You have this figure just like that. You have a Y-like figure just like that. You can basically just take that and you've gotten this. So it's B. C, again, it's not a proper Y. There's something like this, but not a proper Y. In D, you have the beginning of the Y, but you do not have the straight line from the pointer, the vertex of the Y, right? So not this either. So your answer is B. Okay, as simple as that. Moving on. From the answer figures, choose the figure in which the problem figure is embedded. Again, the same thing. This, I need to choose which of these figures has this problem figure. What do I mean by embedded? We actually have a topic under nonverbal intelligence called embedded figures, right? Basically, when you have a figure inside another figure or it's a part of another figure. So I need to see in which of these figures do I have this figure. And by embedded we mean you will have this figure like this itself. It won't be in parts. It won't be that in the figure you will have a triangle somewhere and then a line somewhere and then a cross somewhere. No, it is embedded. What does it mean for it to be embedded? You will have the figure in its entirety, right? So this figure as its whole will be a part of one of these four figures, right? So your time starts now. Right. So here the answer is it's not this. Why? Because you have almost everything. You have the triangle, you have the plus, you have a straight line, but you do not have the horizontal line. So not this. B, again you have the things, but I said, see, when you talk about it being embedded, you need to get that whole thing, right? So you don't have it, so not this. C, again the issue is that you have all of this, but again no horizontal line. D, you see that you have the everything that you need. There is this, okay, there is a triangle, you have a plus, you have a straight line, you also have a horizontal line, right? The horizontal line is already visible there, okay? It's just that you have a couple of extra things. See, when you talk about a figure being embedded in something else, if there are a couple of extra things, it's completely fine. It's not an issue. It's just that the figure should be available, should be present in its entirety. That's all that we're talking about, okay? So yeah, we have done with that. Moving on. Find the total number of triangles in the given figure. Okay, I need to see how many triangles. So for questions like this, I would be discussing questions like this in detail. So we already had, I mean, I think I sort of mentioned this when we discussed counting figures. So this comes under the topic counting of figures. Okay, I might just write it here. I'll just write it here. Okay, so this comes under the topic counting of figures. Now, this is a very famous, type of question where you have a triangle and within the triangle you have many other triangles and you're asked to find the total number of triangles in the figure. So the thing with these questions is that, see, I'll tell you, I'll give you an example. So for example, here you have one triangle. Okay, this is one triangle. You see the small triangle. And then you see this small triangle. That's two triangles, right? Now you have yet another triangle. I'll use a different color. Basically, the triangle that includes both of these is a third triangle, right? So that basically, see, for example, if you have a triangle like this, this is one triangle. And then if it's divided like this is one, and both of these together is also one triangle, right? So here, even if you look at just these two figures, you get how many triangles? 3 triangles already, right? So when you look at this figure, you need to be able to count all such kinds of triangles. So this is one, both of this together is one. And then if you do this like this, again you have another triangle. If you check the parts here, you have another triangle, yet another triangle, and then these together, and then these together, and all of that. So you have a lot of triangles, right? So one way of doing it is obviously counting these triangles, but counting is, I mean, see, you should try to count it for and study. So try counting, just this is 1, this is 1, this is 2, both of these together is 3, then this is 4, this is 5, then all of this together is 6, so 6 triangles in this side, and then do the same thing here. So that's one thing which you should definitely try counting and finding out. But now I'll be telling you a trick to solve these kinds of questions, okay? This trick, you can use it will help you find the answer faster, but for your brain development, I would suggest you to count these. I mean, not for the final exam. When you study, I will suggest you to actually sit and count. The trick is something that you can use for the exam just to get the answer faster, right? But I do not endorse this trick. I'm not somebody who supports the usage of a lot of tricks, because you need to try to do it on your own and sort of, it helps with your development. But anyway, the trick is basically that if you have a triangle, I'll start with a simpler case. So you have a triangle like this that is split here, okay? So in such cases, what you need to see is just take the base. This is the base, right? How many triangles do you have within this base? 1, 2, right? You have 2 triangles under the base. Okay, that's 1 and 2. So the total number of triangles in this figure will be 1 plus 2 equals 3. 3 will be the total number. Now how is it 3? I'll tell you. So 1 is this triangle. Okay, the second one is this triangle. The third one is this whole triangle. If you count this triangle wholly together, it's the third triangle. So that's how you have 3 triangles here. Did you get that? So that's how you do it. So now, for example, if you have a triangle like this and it's split. So here in the base, I'll just draw one more line. Okay. So in the base, how many triangles do you have? 1, 2, 3, 4, 5 triangles. So how many triangles are there in this figure? It's 1 plus 2 plus 3 plus 4 plus 5. What is this? 2 plus 1 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. So there are 15 triangles here. Now, another trick. I'm giving you yet another trick. This addition, it might not be easy for everybody. You know, if you have like, say, 8 triangles, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, it might not be easy. So there is another way you can use. Look at the base, look at the last number in the base, 5, right? Take 5 as n. Have n into n plus 1 by 2 is your formula. So if there are 5 triangles, look at 5. 5 into 5 plus 1 is 6. 5 into 6 by 2. Do you know how we get this formula? Have you studied this? The sum of the first n natural numbers is n into n plus 1 by 2. Right, so when you count 5 triangles here, what you're essentially doing is you're adding the first 5 natural numbers. 1 plus 2 plus 3 plus 4 plus 5. Do you see that? You're essentially adding the first 5 natural numbers. So the sum of the first 5 natural numbers is 5 into 5 plus 1 by 2, which is 5 into 6 by 2, which is 5, 6 are 30 by 2, 15. This is the same 15 we've got in here. So that's another way. If you do not feel like adding everything, you can use this formula. This is the sum of the first n natural numbers formula. So sum of the first 5 natural numbers, that is 1 plus 2 plus 3 plus 4 plus 5 is 5 into 6 by 2. Sum of the first 6 natural numbers is 6 into 7 by 2, and so on and so forth, right? So that's sort of the trick that you can use. Okay, so now this is for questions of this kind. Now, what if you have a question of this kind? This is at the more complex level, right? You have multiple bases. So what you need to do, you need to treat it as different bases. So treat this is the first base. Here you have 1, 2, 3, 4. 4 triangles, right? Now take this second base. Okay, this is your second base. Here you have 1, 2 triangles. This is your third base. Here you have 1, 2 triangles. Now add all of this. So basically you will end up doing, I will remove this part and let me switch to a different color. Okay, so basically just end up adding all of this. So look at the first base, 1 plus 2 plus 3 plus 4. The second base here, plus 1 plus 2. The third base here, plus 1 plus 2. Just add all of these bases together. 1 plus 2 plus 3 plus 4 plus 1 plus 2 plus 1 plus 2. What is the answer? 1 plus 2 is 3. 3 plus 4 is 7. 1 plus 2 here is 3. 1 plus 2 is 3 again. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 7 is 16. Your answer is 16. That's how you get the answer. Now again, if you do not feel like doing 1 plus 2 plus 3 plus 4, you can do 4 into, what's the formula? N into n plus 1 by 2, right? So 4 into 5 by 2. So that is 4 5s are 20 by 2, which is 10. So then you can do 10 plus. If you do not feel like doing 1 plus 2 is very simple. You can just do it. 1 plus 2 is 3 plus 3. 10 plus 3 plus 3 is 16. That's, and yet again you get 16. So that was sort of like a trick to do questions of this sort. But I would suggest you to sort of try and find triangles one by one, right? So just try to visualize what will the triangles be. So, you know, these are the small triangles that you will have. 1, 2. So this triangle, then this whole triangle, this whole triangle, this triangle, this triangle, this whole triangle, this whole triangle. And then you will have both of these triangles together, both of these triangles together, both of these triangles together, and then these three triangles together, these three triangles together, and then there's one whole triangle. So just sort of try to think of all different triangles you can find in this figure. Right, so that try to do it. I mean, this is just a trick to do these questions faster during the exams, but I would highly recommend you guys to sort of try to find out the method on your own. Okay, so yeah, basically the trick is to look at this basis 1 2 3 4 1 2 1 2. Okay, so that's sort of the trick. That's why I included this question, because this is a very famous kind of question that's asked. Okay, with that we are done with nonverbal intelligence. It's a chapter, that went on pretty long. We had to take, 3 example sessions and all of that, but it's worth it, right? I hope so. I hope it was a good class. I hope you are at least thoda sa familiar with the chapter now, and I hope all of you have a good time. We are done with nonverbal intelligence.